Intro. Betelgeuse, the enormous red supergiant closest to Earth, has shown a remarkable decline in brightness in recent years, sparking a wide range of reactions worldwide. Some theories suggest this fading might signal the approach of a supernova, a catastrophic explosion that raises concern among scientists and the general public alike. Betelgeuse, a major star in the Orion constellation, has regained some of its former brilliance after dimming, yet it seems to be entering a phase of reduced activity. Experts are now pondering the future of Betelgeuse and whether its eventual detonation could have any impact on Earth. Orion, one of the most iconic constellations in the sky, is well known for its two primary stars, Riel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the largest and most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary massage ejection in 2019, an occurrence never recorded in any star of its kind. Although coronal mass ejections, CMEs, are relatively common with our Sun, this particular outburst from Betelgeuse is unique and has generated significant intrigue among astronomers. This massive burst of mass expelled by the star was 400 billion times greater than the typical CME observed in stars like ours, briefly obscuring some of its light and leading to its unusual dimming. Estimates regarding the of Betelgeuse from Earth vary, with some placing it as far as 724 light-years away. Measuring the distance to red supergiants such as Betelgeuse is challenging due to their vast distance and unusual traits. Betelgeuse is one of the most luminous stars visible from Earth, shining with about 100,000 times the brightness of our Sun. However, such intense luminosity comes at a cost. Betelgeuse is expending its energy, rapidly burning through its fuel and speeding up its inevitable demise. The star will eventually exhaust its fuel supply, collapsing under its own gravity and potentially triggering a supernova, a violent explosion that might eventually leave behind either a neutron star or a black hole. Assuming current scientific theories hold, does Betelgeuse pose a danger to Earth? If the star were to explode in a supernova, its outburst could have catastrophic consequences for Earth. Supernova are capable of emitting light so bright that it can ride an entire galaxy. Even if Betelgeuse is relatively distant, such an explosion would be hard to ignore. The last supernova observed in our galaxy was in 1604, and the most recent one in 1987 occurred in the Large Magellanic Cloud, 169,000 light-years away. The destructive potential of a nearby supernova remains an intriguing yet concerning possibility. If such an event were to unfold within our galaxy, it could have profound implications for Earth. Supernova, though spectacular, are much less powerful than gamma bursts, GRBS, which are on an entirely different scale. While supernova have the potential to obliterate biospheres and blanket planets in deadly radiation, it is their ability to strip away a planet's ozone layer that is particularly troubling. A weakened or destroyed ozone layer exposes the planet to harmful ultraviolet radiation, which could result in an extinction event. The initial radiation burst from a supernova is dangerous, but the more insidious threat comes in the form of cosmic rays that arrive hundreds of thousands of years later, capable of further damaging the planet's surface and potentially preventing life from recovering. Historical records show evidence of past supernova. For example, traces of iron-60, a radioactive isotope formed during supernova explosions, have been detected in Earth's oceans and lunar regolith, suggesting that the Earth may have been affected by supernova within the past few million years. Although astronomers have ruled out any imminent supernova threats, they have discovered another potential risk. Certain types of supernova emit radiation that can travel vast distances and inflict damage on planets like Earth. When a star nearing the end of its life is surrounded by a substantial amount of material, a specific type of supernova may occur. The shock wave from the initial explosion strikes the surrounding disk, triggering the emission of vast amounts of X-ray radiation. This high-energy radiation has the potential to deplete a planet's ozone layer by as much as 50%, which could induce an extinction event within a range of 150 light-years. Fortunately, no such X-ray supernova are currently known to be near enough to Earth to pose a direct threat. These findings have caused astronomers to reconsider the boundaries of the galactic habitable zone, the region within galaxies where life is likely to exist. Star formation in the outer regions of a galaxy is too low to create the necessary elements for rocky planets, while the inner regions where stars are born and die quickly are hazardous due to frequent supernova irradiating the surrounding areas. This research suggests that the inner boundary of the galactic habitable zone may be farther from the galactic center than previously thought. How would Betelgeuse supernova appear from Earth? While the biosphere on Earth would likely remain intact, the spectacle would certainly be impossible to miss. According to astronomers Goldberg and Bohr, Betelgeuse's explosion would result in a luminosity roughly half that of the full moon, visible for several months. This brightness would be visible even during the daytime and cast shadows during the night for several years after the explosion. The supernova's remnants would continue to be visible to the naked eye. Although Betelgeuse's supernova would be a fascinating event, it would not be without consequences. The global fascination with such a phenomenon would be undeniable, but the long-term implications for Earth environment remain uncertain as scientists continue to monitor this red supergiant. We can only wait and watch, hoping that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning sight, but not without significant consequences. The enormous burst of light from such an event would likely be the second brightest object in our sky right after the sun. During its peak, it would shine with an intensity so great that it could easily outshine the moon. This would cause the star to become visible during daylight hours, casting visible shadows in the darkest of nights. The sheer brilliance would captivate observers worldwide despite its blinding light. It's important to note that visible light emitted by a supernova accounts for only a small fraction of the total energy produced. The more pressing concern is the high-energy radiation released, typically in the form of gamma rays and X-rays. These forms of radiation are extremely dangerous and have the potential to strip the Earth's ozone layer, a protective shield that prevents harmful ultraviolet rays from reaching the surface. Without this layer, life on Earth would be exposed to dangerous levels of radiation, increasing the risk of a mass extinction event. The aftermath of the explosion would not end with the immediate burst of energy. Cosmic rays, subatomic particles, accelerated to nearly the speed of light, would follow, continuing the devastation. By bombarding the planet for hundreds of thousands of years, these particles have the power to penetrate Earth's atmosphere, further degrading the ozone layer and potentially altering the course of life on the planet for millions of years. The effects of such an event would be long-lasting, preventing ecosystems from recovering and possibly stalling the re-establishment of life on Earth. While we have not experienced a supernova of this magnitude in our own galaxy for centuries, there is growing evidence that such events have occurred In the past, traces of iron, a radioactive isotope produced during supernova, have been discovered in sediment layers and lunar soil samples, hinting that Earth may have been exposed to the fallout from a nearby star explosion within the past few million years. Though no immediate threats from supernova are predicted, the knowledge of their potential dangers has prompted astronomers to keep a close watch on nearby stars, including Betelgeuse. What happens next? Researchers have also uncovered another type of supernova that could pose an even greater risk. In some cases, a star's final explosion can be surrounded by a massive disk of gas and dust. When the shock wave from the explosion collides with this material, it generates an intense burst of X-ray radiation. This high-energy radiation can travel vast distances and has the potential to significantly deplete the ozone layer of any planet. Within a certain radius, a planet exposed to such radiation could face catastrophic consequences, including the triggering of an extinction event. Fortunately, no stars exhibiting this type of X-ray supernova are known to be located near Earth. However, the discovery of this new type of supernova has caused astronomers to rethink the boundaries of the galactic habitable zone, the region of space where life is most likely to exist. Previously, scientists assumed that the galactic habitable zone extended farther from the center of the galaxy. However, new evidence suggests that the inner regions where stars are born and die quickly may be far more hazardous than previously believed. The frequent supernova in these areas could irradiate planets in their vicinity, making them inhospitable for life. This has led scientists to propose that the outer boundaries of the galactic habitable zone may extend farther than originally thought. Scientists continue to study Betelgeuse and other stars in similar stages of their life cycles. The potential for future discoveries grows. The study of these stars not only provides insight into their eventual fate, but also into the broader processes that govern stellar evolution and the life cycle of galaxies. Understanding how stars like Betelgeuse end their lives is crucial for predicting the conditions of our own Sun's future. While the Sun is not expected to end in a supernova, its eventual transformation into a red giant will have profound effects on Earth. In addition to its potential to affect the solar system, the behavior of supernova can also inform our understanding of cosmic phenomena like galaxy formation and the chemical composition of the universe. Elements such as iron, gold, and uranium are created in the explosive aftermath of a supernova, dispersing across space and enriching the interstellar medium. These elements are integral to the formation of planets and life as we know it. In this sense, supernova, though destructive, play a vital role in the ongoing cycle of matter in the universe, creating the building blocks necessary for the creation of new stars, planets, and potentially life. Astrophysicists are constantly refining their models to better predict when and where supernova are most likely to occur. One approach involves monitoring the chemical composition of nearby stars and their surroundings by detecting the signature of elements such as helium, hydrogen, and carbon. Astronomers can infer the processes happening inside these stars, for example, an increase in certain isotopes or unusual energy emissions could signal a star's impending collapse. Another method involves studying the behavior of binary star systems, two stars that orbit each other. In some cases, one star in a binary system can accrete material from its companion, pushing it past the critical threshold where it can no longer support itself, leading to a supernova. While there is much to learn from stars like Betelgeuse, there are still many unknowns when it comes to predicting the exact timing and nature of a supernova. Stellar explosions occur on timescales of millions to billions of years, making it challenging to observe their final moments in real time. However, advancements in technology such as the use of large-scale telescopes and sophisticated computer simulations are allowing scientists to better model the behavior of stars as they approach the end of their lives. These tools help researchers identify precursor signs, allowing for more accurate predictions and the possibility of observing a star's death up close. Moreover, the detection of gravitational waves, ripples in spacetime caused by massive objects like supernova, has opened a new frontier in the study of stellar explosions. By detecting these waves, astronomers can gather real-time data on events that were previously beyond our observational capabilities. This breakthrough could offer a deeper understanding of the processes behind supernova, further refining our knowledge of these cosmic phenomena and their potential impact on Earth. Researchers continue to examine stars in their final stages. They are also expanding their focus beyond just supernovae. The study of red supergiants like Betelgeuse has revealed fascinating insights into stellar mass loss, a process in which stars expel vast amounts of their outer layers into space. This loss of material has profound implications for the surrounding environment, enriching the interstellar medium with elements that will eventually form new stars, planets, and potentially even life. Stars like Betelgeuse are known to shed material in massive amounts, contributing to the cosmic dust and gas that forms the building blocks of future generations of stars and planetary systems. This mass loss also plays a key role in regulating the life cycles of galaxies themselves. As massive stars die and explode in supernova, they not only influence their immediate surroundings but also contribute to the formation of new stars and the overall evolution of the galaxy. Understanding the details of this process allows astronomers to gain a better sense of how galaxies evolve over time and how they will continue to change in the distant future. In fact, star formation is often closely linked with areas of stellar death, as the energy and material released by supernova provide the necessary conditions for new stars to form. A particularly exciting avenue of research involves understanding how supernova can trigger the formation of black holes. When a massive star reaches the end of its life, it may undergo a supernova explosion and leave behind a remnant core. If this core is sufficiently massive, it can collapse under its own gravity, forming a black hole. These enigmatic objects are not only fascinating in their own right, but their study can also shed light on other cosmic phenomena, including the nature of spacetime, the formation of galaxies, and even the fundamental forces that govern the universe. The discovery of so-called parent stability supernova has added another layer of complexity to our understanding of stellar deaths. These rare events occur in stars that are significantly more massive than Betelgeuse and can result in the complete destruction of the star, leaving no remnant behind. While such events are exceedingly rare, their study could reveal important information about the most extreme conditions in the universe, pushing the boundaries of astrophysical research. One of the more intriguing aspects of researching supernova is the possibility of detecting them in real time. The use of advanced telescopes and satellites such as the James Webb Space Telescope is allowing astronomers to study stars in unprecedented detail. Even before they explode, these instruments can capture subtle changes in a star's light output and chemical composition, offering clues about when and how the star will eventually meet its violent end. With these tools, scientists may be able to predict future supernova with greater accuracy, providing an exciting opportunity to witness a cosmic event firsthand in the future. These advancements in technology and research could also lead to a better understanding of how the universe's most massive stars influence the evolution of life on Earth, while the immediate threat posed by a supernova from Betelgeuse may be far off. Ongoing research will continue to offer valuable insights into the cosmic forces shaping our universe.